Today we're working on Lesson 3, writing products as sums and sums as products. For our opening exercise, George and Benjamin have a sum of money that has a ratio of 3 to 4. If the sum of money was $56, how much did George get? So we're going to start off and we're going to identify what George has. And George has 3 units of money. Benjamin has 4 units of money. These are called tape diagrams. And those 4 units of money together must equal $56. So as we look at this, there are a total of 7 units that equal 56. So what is the value of 1 unit? I'm going to label this X because it's unknown. So the value of 1 unit would be equal to 56 divided by 7. So 1 unit is equal to $8. So how much does George have? George has 24, or received $24. Represent 3 plus 2 using a tape diagram. So 3 plus 2. Notice my units are the same size, and we have 3 plus 2 for a total of 5 units. We could also show that this way without splitting the units and just identifying the size of it. So that is another option. Now what if we have a variable? We don't know what the size is. So we're going to just identify X as any size we want. I'm going to say that's X because it's unknown. And I have 2 same size units here, and that would be standing for 2. Let's take a look at a rectangular array, and you probably are familiar with those from elementary school when you did multiplication facts. So I'm going to start off here, and I know that I'm going to need a total of 3 groups. And those 3 groups are 3 plus 2. So I'm going to start off and identify my 3 plus 2. And how many groups of those do I need? We said that I need actually 3 of those groups. And these should all be the same sizes. So we may have to use our imagination if they're a little bit off. So this was our groups of 2. This was our groups of 3. And there's the total. So as we move forward, we're going to look at 3 times X plus 2. So we're going back to what we did previously. And I have my X. Didn't mean to put that there. We'll hold off. And then I have 2. And I need 3 groupings of this combination. Okay, so now I have x's, and I have 2, and there's 3. So if I take a look at this, I'm looking at the combination of 3 groups of x, which is 3x, and 3 groups of 2, which actually makes 6. So now, when we look at those, that leads us to think a little bit about the distributive property and these combinations and what they stand for. So the distributive property is defined as A times B plus C, that's in parentheses, is equal to AB plus AC. Okay. Notice that this is a product. It's a product because it's a multiplication problem. It's A times that grouping. But this is an addition problem, which gives it a sum. So we're looking at finding a sum of this one, and this one we're finding a product. We're not going to worry too much about the drawing and the model part. We can take a look at, we're going to be doing several of these in these next sections. So exercise 1. Determine the area of each region using the distributive property. So remember that area is equal to the length times the width. And we have 11 by 16 here. And then 11 by 5 here. So there's a combination. So we have 11 times 16, which totals 176, that would be units squared if we were looking at the true area. And then we have 11 times 5, which gives us a total of 55 units squared. So if I wanted to find the area of this entire figure, I would combine these two. So can you imagine if we had to actually draw 11 rows by 16 rows by 5 rows? That's a lot of drawing. So this way we can show the distributive property of 11 groups of 16 plus 11 groups of 5. Going back to that multiplication piece. Draw a tape diagram to represent each expression. Well, I have a group of x, y. So x plus y. There's one group. And then I'm adding another x and y. And one more of these. That's not the most accurate picture. So when we look at these, we can see that I have a group of x and y, so x plus y, and another group of x plus y, and another group of x plus y. This is called expanded form. And it's expanded because we're seeing every individual x and every individual y. So what happens here? Well, I have 3 x's And then I'm combining or adding the three y's. Do you see a relationship or any kind of connection to the problem up above? This one is also an expanded form because, again, I'm seeing all the individual x's and all the individual y's. So the like terms are not combined. So hopefully you're seeing my three x's. I've now combined my x's or grouped them together, combining these like terms in the tape diagram. So we're moving down to 3x plus 3y. So now we're actually doing a full combination. So now you're seeing how I've actually grouped these together. This is called standard form. Because I have combined and put together an expression where my x's are combined together with a coefficient, and my y's are combined with their coefficient, unlike up here, where each one is identified separately. You could even possibly see this written or illustrated like this. Three sets of x, three sets of y, or three groups. So how is this different from down at this bottom part? Well, in this bottom, I am identifying, if you think about this, take a look here. I have an XY and an XY and an XY. So I have three groups of XY. But we may find that it's more efficient to draw it this way. This is my X. This is 3. That's telling me how many groups. And here is my Y, and also 3. And it goes back to when we found the area a few minutes ago. And we do the 3 times X, because that is distributing, which forms 3x, and then a 3 times the positive y, or the plus y, and I get the 3y. So now you're beginning to make those connections. 3x plus y also gave me 3x plus 3y. And that is our definition of the distributive property. Finding the product, the sum. We will continue with part 2.